Hello guys, welcome to another video. Today we will be discussing about formal charge. So when we study about the polyatomic molecules or polyatomic ions, so we used to write like NO3 minus or CN minus or like that, OH minus, OH ion minus. But in organic chemistry we should know where is the negative charge or positive charge is concentrated. Like in the NO3 minus, okay, actually the nitrogen is positive charge and these two oxygens are negative charge, then thus we will get the overall negative charge. Okay, sorry, and thus we should know how to calculate the formal charge. So in order to calculate the formal charge, the equation we use is formal charge is equal to number of valence electrons minus number of bonds. Just count the number of lines and number of dots, that is electrons that do not participate in the reaction, number of dots. So I will write clearly number of valence electrons minus number of bonds minus number of dots. Okay, so let's start with this nitrate itself. So for this nitrate, so you will know how to calculate. So this oxygen has 1 2 3 4 5 6 1 2 6 and 2 3 4. Okay, so if we calculate the I will give the number with this. Okay, 1 2 3 and 4. Okay, if we try to calculate the formal charge of, let's say, oxygen number 1, it will be number of valence electrons is 6 oxygen for oxygen. So number of bonds is oxygen is bonded with 2 bonds minus 2. Okay, and oxygen has how many dots? 4 dots. 4. 6 minus 2 minus 4, that is 6 minus 6, so it is 0. So this have 0 charge. Okay, and going to the next carbon, sorry, next oxygen number 2, it is 6 valence electrons minus 1 bond minus number of dots are 6, so there is minus 1 charge. And going to oxygen number 3, it is 6 minus 1 bond minus 6 electrons for 6 dots, so minus 1. So now it is 2 minus charge, but as you can see here it is only 1 minus charge. So how does it becomes 1 minus charge? Because the nitrogen, will calculate for nitrogen, formal charge for nitrogen equals, so for nitrogen valence electrons is 5, so number of bonds 1 2 3 4 4 minus no free electrons, so it is so equals plus 1. So here the nitrogen is plus 1 and these two oxygens are negative. Okay, so this is having no charge, this oxygen is having no charge. So nitrogen, here the nitrogen is positive. Okay, similarly we can calculate for other molecules also, other ions also. Okay, so let's see another example for ozone. So how can we calculate the formal charge? We'll check. So as we say, formal charge equal to number of valence electrons minus number of bonds minus number of dots. Okay, then if we calculate formal charge equal to, like, we'll number 1 2 3. Okay, formal charge of number 1, oxygen 1, is so 6 minus number of bonds is 2, number of free electrons, that is number of dots, 4, so 0. Okay, again this is having 0, and next we are calculating formal charge on 0 2. So here 6 minus number of bonds are 3 minus number of dots are 2, so 6 minus 5, that is plus 1. So this here, this second electron, it is plus 1, and going to the formal charge of third oxygen is 6 minus 6 minus 1 bond and minus 6, so here it is minus 1. Okay, so it is here, it is minus 1. Okay, let's see another example for this oxygen. Sorry, for this oxygen we can calculate the formal charge of this oxygen. So formal charge equal to number of valence electrons is 6 for oxygen, and for number of bonds is 1 2 3, and number of dots, that is 2, so it is 5. And okay, another example we can write is for sulfur dioxide. Okay, so sulfur dioxide, so formal charge of sulfur atom, formal charge of sulfur atom is equal to 6 valence electrons minus 1 2 and 3 bonds, so 3 bonds and 2 dots. 6 minus 5 is positive 1. Okay, so it is a positive 1. Okay, let's calculate also the oxygens here. So I will first number the oxygen. Here is 1 and oxygen here is 2. Okay, so formal charge on oxygen 1 is 6 minus number of bonds is 2 and number of dots are 4, So 6 minus 6 equals 0, and formal charge on oxygen 2 is equal to 6 minus 1 minus 6, that is minus 1. Okay, so let's calculate the formal charge of the sulfur dioxide. And here for sulfur, okay, here for sulfur it is, so 6 valence electrons minus number of bonds is 3 and number of dots are 2, so it is 6 minus 5, that is plus 1. So here I'll put a plus 1. And for the second oxygen it is 6, so the first oxygen it is 6 minus the number of bonds it is 2 and number of electrons it is 4, that is number of dots is 4, and it is 0. So here it is 0, so I am not writing anything. And here we again calculate for this we calculate is 6 valence electrons minus 1 bond minus 6 dots, that is minus 1, so here it is minus 1. Okay, now we can also go to another example of hydronium ion. So okay, if we calculate the formal charge of this ion at formal charge of this oxygen is 6 minus 3 minus 2 dots, that is 6 minus 5 equals plus 1. So we all see, so this hydronium ion, so this positive charge is concentrated onto the oxygen. Okay, I hope you understood the formal charge. So formal charge is very important in the organic chemistry, so we can know where is the charge is concentrated on the organic molecules. Okay, then see you in the next video. Bye. Make sure you subscribe to this channel. Make sure you subscribe to this channel and press the bell icon. Okay, see you.